Okay, we are going to take 2 ionic salts, iron 2 nitrate, and barium sulfide, and we're going to determine whether soluble or insoluble and predict products for them and see if we have a precipitate. So we're going to take iron 2 nitrate and we're going to look up nitrates. On the solubility chart, all nitrates are soluble. So iron 2 nitrate is going to be aqueous. And then we have barium sulfide. All sulfides are insoluble except group 1 or group 2, and ammonium. Barium is a group 2 metal, so it's going to be soluble as a sulfide. So we got 2 aqueous reactants. Now, the double replacement reaction, the metals, barium and iron 2, we're going to switch places. And we got our 2 products, iron 2 sulfide and barium nitrate. Now, we already know that all nitrates are aqueous or soluble, so we're going to put an AQ here. We're going to look up iron 2 sulfide and see what it looks like. Okay, if we go to this side, we see on the third bullet here, all sulfides except group 1 and group 2 and ammonium are insoluble. Iron 2 is a transition metal, so it's not group 1 or group 2, so it's going to be insoluble, which means that we give it the demarcation of S because it's going to form a solid precipitate. Okay, now we're ready to write our molecular equation, which is our double replacement reaction here. So we're going to write iron 2 nitrate is aqueous, and you have to put the state of matter here, and barium sulfide is aqueous, yields iron sulfide solid plus barium nitrate, okay, and that's aqueous. All right, let's balance this. We've got a barium ratio of 1:1 for the product and reactant side. The iron, we have 1:1. It's easy to start with your metals, and usually the anions fall into place. Nitrate, we've got 2 and 2. And sulfide, we've got 1 and 1. Okay, so we're balanced here in a 1:1 ratio. So we're ready to take our aqueous compounds and break them apart into ions because they're going to dissolve in water or dissociate. So we've got iron 2 plus aqueous plus 2 nitrate. It's a -1 charge because it's got a subscript of 2 down there. Plus barium 2 plus sulfide 2 minus. Okay, those are our reactants. And then we got our precipitate. Iron sulfide is going to stay a solid, plus barium 2 plus 2 nitrate minus. Okay, so we make sure we got the right number of everything. We got 1 iron on each side, 1 sulfide, 1 barium, and 2 nitrates. Okay? The only thing that does not come apart into ions is our precipitate. So now we're looking for changes or that could indicate there's a chemical reaction happening. So we're going to start with iron on the far left side here. Iron is an ion on the reactant side, and then it becomes part of iron sulfide over here, so there's definitely a chemical change happening. It's not exactly the same. Nitrate, on the other hand, is an ion here and an ion here. It's called a spectator ion. It's still in solution, but it doesn't react, so we're going to cross it out of our net ionic equation. And then barium 2, the same thing. It stays an ion floating in the solvent, so we cross it out. Sulfide becomes part of iron 2 sulfide, so we leave that. And then we write our final equation, what actually changed. Actually, underwent a chemical reaction. We got iron 2 plus sulfide 2 minus, aqueous, and then we yield iron sulfide, which is our precipitate, and it is balanced. So we're done. That's your net ionic equation for a precipitate reaction.